Hi everyone, I'm Shannon Locke, a postdoc at the ENS in Paris, here to discuss sensorimotor confidence for visuomotor tracking. The study I'm presenting today was done in collaboration with Pascal Mamassian at the ENS and Mike Landy at NYU. Voluntary sensorimotor behavior is composed of three elements. First, the goal, what the movement is trying to achieve. Second, perception, the quality of the sensory signal. And third, the executed action, which can differ from the intended action due to motor noise. Sensorimotor confidence is a subjective evaluation of perceptual and motor performance with respect to the goal. Sensorimotor confidence is ubiquitous in everyday life. These evaluations might determine if we jump on slippery rocks, sign up to play a sport, or continue driving after visual decline. Yet there are few empirical studies investigating this form of confidence. As a first step, we sought to test if sensorimotor confidence was based on expectations about difficulty or from monitoring of error. We investigated sensorimotor confidence using a tracking computer game. The participant moved a black cursor with the mouse to track the center of a dot cloud as it followed an unpredictable random walk. At the end of the trial, they reported their confidence in their tracking as either better or worse than their average. To compare confidence ratings to objective performance, we developed a new metacognitive sensitivity metric. Objective performance was quantified as the root mean squared error between the cursor and the tracking target. We then split trials into two groups according to the confidence report, those classified as better than average and those classified as worse. This graph shows the error histograms of an example participant who often correctly reported better for low error trials and worse for high error trials. Metacognitive sensitivity was then quantified as the overlap in these distributions via an ROC-style analysis. For no sensitivity, the two error distributions would be completely overlapping, giving a sensitivity score of 0.5. Perfect classification would have no overlap and a score of 1. Intermediate sensitivities result in scores between 0.5 and 1. In experiment 1, we manipulated task difficulty in two ways. In one session, we varied the size of the dot cloud, affecting the quality of the perceptual information. Here are the measured ROC-style curves of our 13 participants. On average, they scored close to 0.7, indicating some degree of metacognitive sensitivity in their confidence judgments. In the other testing session, we varied the velocity stability, affecting the difficulty of the tracking action. We found a similar level of metacognitive sensitivity for this difficulty manipulation. We then applied the metacognitive sensitivity analysis to 1-second time bits. For both difficulty manipulations, this revealed a recency effect. There was greater separation of the better and worse error histograms for error later in the trial compared to error earlier in the trial. This indicates error towards the end of the trial had a disproportionate influence on the confidence judgment. To investigate the recency effect further, we repeated the task with 7 new observers in experiment 2. This time, we did not vary the cloud size or the velocity stability, but instead we varied the tracking duration. Now, the participants could not anticipate when the confidence judgment would be required. Did this encourage them to equally weight the error throughout the trial when assigning confidence? No. As you can see, there is a recency effect for each of the trial durations, with the final few seconds having a disproportionate influence on confidence. For the 10-second trials, we replicated the effect observed in experiment 1. Our results suggest participants consciously monitored their tracking error to assign sensorimotor confidence, and this performance monitoring was biased towards the most recent error. Thus, our recent experience plays a large role in how confident we are in our sensorimotor behavior. If you're interested in this study, you can find more details in our recent publication noted here.